and then talk about their properties, and then we'll get into the lab. Okay, so once again, in ionic, that's where the electrons are being transferred, right? One of them says, I'll give mine to you, and then we're stuck together because of our differences of charge, right? Remember we talked about that puppy analogy, right? Where if I have a puppy, but then I give it to Camille, but then I still hang out with Camille because she has the puppy, right? Positive and negative still attract. Okay, covalent is just sharing, and then metallic is where the puppy runs around the room. Okay, the bond forms, so this is how you identify the formula. Okay, if the formula is a metal and a non-metal, it's always ionic. If it's two non-metals, it's always covalent. And then if it's two metals, it's metallic. Okay, just a friendly reminder that you do get a note card on the test if you make one. Okay, so this type of information that's just kind of memorizing might be a helpful thing to write down if you are prone to forgetting. Okay, but you have to make that yourself. It has to be 3 by 5 in size. I don't have any today for you, so you need to use your own or just cut out a piece of paper, but it has to be 3 by 5 inches. If it's bigger, then I'm going to cut it on test day. And whatever gets cut.
That's awesome.
Okay? Okay. Other properties. Ionics are typically brittle. These are the ones that when you do the malleability test and hit it with the hammer, they shatter. Okay? Covalents can go either way. Sometimes they're brittle, but sometimes they're not. For example, in the lab last time, the wax. Is wax malleable?
Yes.
Very so, right? But wax is a covalent substance. Is sugar malleable? No, but sugar is also covalent. So covalents can go either direction of being malleable or not malleable. Sorry that these don't look like they're quite in order of the boxes on your paper, are they? They are? Okay.
Oh,
Okay.
I'm just writing.
You're just writing in a different order. That's okay. I just want to make sure. Okay, and then luster's shininess, right? So metals are typically shiny. Now, where could you be deceived? Is there times where a metal may not look shiny? Yeah, right? Especially if it's rusted or dirty. So you could be deceived, but if it's nice and clean, metals are shiny. These ones, ionic and covalent, really aren't. Sometimes ionic have they're sparkly, sometimes people would say, because it's like salt. So salt can sometimes look sparkly, but we wouldn't consider that lustrous.
Wait, what is that? One that they're covalent. Oh no, I'm gonna say.
Brittle when polar.
I don't know what.
So if they're a polar substance, they're brittle, and then they're malleable when non-polar. For melting points, the ionics are very, very high. These are the ones that will not ever melt on our hot plates. Our hot plates don't get hot enough. For example, to melt salt, you have to get up to like 950 degrees. Right? Things can get that hot, but not our labs. So those will never melt on our hot plates. Covalents are typically low. Those are the ones that melted. Sugar melted, the wax melted. Those are typically the low ones. And then the metallic ones are in between. On our hot plates, to be honest, metals won't melt. But we can melt metals without sometimes too much heat required. So they're kind of in the middle. Okay, and then conductivity. So as a solid, metals are the only thing that conduct in solid form. This is a very for sure test. If something conducts as a solid, it has to be a metal unless something's wrong with your conductivity meter. Okay, these two will not conduct as solids. Aqueous solubility, which is whether it dissolves or not. Okay, metals are not soluble in water. They don't dissolve. Ionics are always soluble in water. Covalents, once again, can go either way. Once again, for example, does wax dissolve in water? No, and that's a covalent substance. Does sugar dissolve in water? Yeah. Right, so covalents can go either direction, where some will dissolve but some will not. And then for aqueous conductivity, ionics are always conductive. Now, it might not always be super high, but it's normally on their higher spectrum. Covalents, if they dissolve, will often conduct weakly. Once again, if something doesn't dissolve, like it doesn't do this test, then this test doesn't even apply to it, hence with metals, right? Since they don't dissolve, then it doesn't do aqueous conductivity. Any questions about any of our lab tests you did last time or the data we get from it? Now, what are some things you should need to be careful with that maybe you noticed that could deceive you with lab data? What are maybe some errors that we need to be aware of that you might see and be like, oh, it's going to be ionic, but it's just an error in what you did? Yeah, Jeremy.
Obvious conductivity, if you're like touching the actual bottom of the material, that can affect it.
Yeah, I'd say this is a great test, but you gotta be very careful, yeah. If you're touching like the bottom, right, then it could actually say it conducts because you're touching the metal, right? Great one, have a smiley face. Other possible errors we need to be aware of, or that maybe we came across. Then you guys identified one last time. What was the problem you guys came across?
They were all conducting water.
Yeah, so there is a problem with this test if your cells are dirty already. If they didn't get cleaned out well, then it could conduct even though the new sample isn't conducted. So this is a great test, but there are possibilities of it giving you false data. So kind of just something to be aware of. Another one to be careful with is with how you interpret melting. In terms of, is it actually melting or is it burning? That can also kind of deceive you a little bit in your claim that you choose. So, okay, any other questions about the test for now?
Can our note card be double-sided?
Yes. Yeah. Good question. Okay, so everyone take a look. Did everyone get one of these as you came in? Did I miss anybody? Thank you. Okay, so you can work with the same lab group you did last time if you weren't, I think you were all here. I think some people are just missing, some people lost their lab group. So if you're missing a lab group, we'll find you a group. Otherwise, you can just work with who you did last time. Okay, so before you can come into the lab, you need to complete questions 1, 2, and 3, where you decide, okay, which test are we going to do and why are we going to do them? It's totally up to you of what you think, you and your group, of what you feel is going to be best. But you just have to pick which test you're going to perform. After you pick your test, then you'll come to the lab door and I'll assign to you 4 unknowns. Number one big thing, you've got to write down which cup numbers I give you. Because that's very important, otherwise I won't know what you tested. Okay? This back side right here, question 4, and then the 5, or follow-up, you're going to do those after the lab. So those are some after lab questions that you'll do. Okay? You'll gather your data here, and then on this last page is where you'll practice making your claim. Okay, so in this reasoning box right here on the back, format your reasoning like you need to for the test to practice it. I also highly recommend and encourage you, and you can, once you come up with your claim, let's say you think sample 3 is a metal, check with me and I'll tell you if you're right or not. Because we don't want to be drawing wrong conclusions today, thinking we're right, and then do that same thing on the test. So maybe before you write your reasoning, just call me over and I'll let you know, like, yep, those are right, or then we can figure out what went wrong in the lab. Okay, lab shouldn't be very long because you're only doing 4 samples and you only have to do 3 of the test. But once you're done, as always, make sure your areas are cleaned up, wash your hands, and then you can come back into the classroom to work on your reasoning and follow-up questions. Any questions of what you're doing? Okay, ready, set, go. Decide what test you're going to perform.